All right, hi everyone. Looking at you, I get a bit of vertigo. And if you go back in time, back in 2013, we hosted BayLearn at Facebook. And Sami Benjo had emailed me at some point towards the end of 2012 saying, hey, we have this new conference called BayLearn. And like 2012 was BayLearn 1. It was the first edition ever. And he's like, we're looking for a place to host it. And I'm like, well, how many people do you think are going to show up? And he's like, I don't know. We had just over 100 this year, so maybe call it 150 or something like that. And so I started to work with facilities, and I'm like, where do we have a room at Facebook that can host, let's call it 200 people, right? So we found a room, and we organized BayLearn, and I have so much respect for Alessa and for the ROAR team, for the research operations and academic relations team at Facebook for doing it this year. Last year, when I asked them, I said, hey, BayLearn is now looking for a new venue. I think it's going to be a lot bigger, right? And this building you're in was actually under construction. So it was a bit of a gamble to say, like, well, is it going to be ready on time? Well, luckily, it is ready on time, and we're incredibly happy to be able to welcome you here. I want to talk a little bit about AI at Facebook, and I'm going to do so by picking 4 quick things that I think are quite exciting. So the first 2 have one aspect in common. I suppose everybody's familiar with the ImageNet dataset. Earlier this year, a small team here at Facebook came up with a pretty crazy idea in a way. They said, well, what if we try to get our hands on the biggest possible labeled data set, except the labels are going to be a little bit imperfect and noisy, right? So the team used Instagram hashtags as labels on public Instagram images, all right? And they gathered a data set of 3.5 billion images. And what they did is they pre-trained on this data set, knowing very well that there's no mapping, there's no correspondence between those labels and the labels in the ImageNet data set, but augmenting the tiny ImageNet data set with this monster 3.5 billion weekly labeled images propelled the team to the best results on top 1 accuracy for ImageNet. And actually, I was checking a moment ago before walking in, they still hold the first place. So that's pretty amazing. So I think the lesson there is that semi-supervised learning works. And a much more recent example is the machine translation team at Facebook recently managed to make one of the biggest leap forwards in accuracy we've seen in a long time in English to German and French to English. Also in this case by using fully unsupervised data, masses of it. And this is my last slide. The other thing that I think is quite interesting is the way, not only Facebook, but I think the way the entire community, right? So for those of you who are in industry, if you think about it, you do come to a lot of these events and you collaborate a lot with people that you maybe went to college with, irrespective of whether we're in the same company or not, right? And I think being here is a celebration of the fact that, we're all researchers in a way, right? And we're all trying to solve hard problems. So PyTorch, and in particular PyTorch 1.0, is a really awesome collaborative effort as well, where what we've taken is we've taken the original PyTorch, which was a Python front end to Torch, and then another project we had in-house called Cafe 2, which was geared for performance, and we basically put them together, and we're using it at Facebook to go from research to production as fast as possible. It's all obviously open source, and it's a beautiful collaborative effort there's a long list of collaborators, I'm not going to name them all, but including Microsoft, including Amazon, including NVIDIA, and a long list of other collaborators. So you should check it out. And then, like many of you, we also do projects with the external world. So this is FastMRI is a project together with NYU, where the observation is that whereas some scanning techniques like X-rays or a CT scan are very, very fast, so if you're a patient, you're like in and out, within a few seconds, In MRI scans, often you have to be holding your breath and you have to be in the machine for up to an hour, right? And the reason is you have to collect a ton of data, right? So what the team was able to prove is that you can actually get away with a tiny fraction of the data and then just use computer vision models to actually reconstruct the images as if you had gathered all the data, right? So for the patients, it's a big improvement. You can actually be there, only a couple of minutes instead of an hour. All right, so I think with this, I'm gonna get out of the way and let you guys enjoy the conference. Thank you for coming. It's an absolute pleasure to be here hosting this event. And I think Jeremy is gonna come back on stage to introduce the program. Thank you and welcome.